Hey everybody, it's Dr. C here. Welcome to episode 94 of All This Science, the science podcast that describes some sciencey thing in 5 minutes or less, raw, unedited. Today, it's all about acids and bases. Cue clever title, the Prose and conjugate bases. I'm proud of that. In chemistry, there is pure distilled water which has equal numbers of hydronium, H3O+, and hydroxide, OH- ions. Dump in some other chemical, like citric acid, and you will tip the balance. You will have more H3O+ than OH-. We call the solution acidic. Start over and dump some toilet bowl cleaner, like Drano, into the water, and the balance will favor hydroxide over H3O+. This podcast sponsored by Drano. Rid those pipes of baby wipes. The conjugate base of an acid is a species who grabs a proton to become that acid. The difference between them is exactly one proton. pH is a measure of acidity. The greater H3O+ you have, the lower the pH. pH actually being the negative log of the H3O+ concentration in moles per liter. A titration is an experimental method to determine how concentrated an acid or a base is. It also helps identify the acid or base sitting in the Erlenmeyer flask. The solution doing the titrating is in a long glass cylinder called a burette. But rather than giving all the rest of the vocabulary, you can just look that up in any chemistry textbook, why not just write some poems and prose about them? That's what we're going to do. We're going to be professional. Here we go, three promes. It's a bit of prose, a bit of poems. And you have my permission to use them for any non-nefarious things that you'd like. And if you want me to send them as separate MP3 files to you, I can. Email me allthisscience@gmail.com or tweet me at allthisscience for that. So here we go with poem number 1, and it's called Titration Consternation. I am a hydronium ion. At least I think I am. Yeah, I'm positive. I swim in originally distilled pristine water. H2O, yeah. I am in an Erlenmeyer flask, better than a protein in an Oscar Mayer flask. I like my existence. I am acidic, not agnostic, not Hasidic. The chloride bumbles about, not daring to take a proton from me. For I am a strong acid, hydrochloric acid, muriatic acid, HCl of an acid. But wait, a disruptor enters. Phenolphthalein, once used in X-lax, but now lacking intestinal fortitude. Why is this weak acid present with its organic transparent grin? A new invader drips in, some sodium cation and hydroxide anion. I'm not lie-in. I'm scared. This is a threat to my very being. For the hydroxide grabs a proton from me. I am being neutralized. I am becoming like the other H2Os in the stream. I have lost my individuality. A few more drops and the pH spikes to 7. The phenolphthalein turns pink. I am done. Thank you. That was Titration Consternation, an original by yours truly, Dr. C. Here comes the second one, Titration Curves. Do you like titration curves? I do not like titration curves. Would you like them strong with weak? I would not like them strong with weak. I do not like this plot you seek. Would you like the drip automated? I would not like the drip automated. I'd rather have the burette cremated. Would you spin the orange stopcock? I will not spin the orange stopcock. I'd rather be doing Hartree Fock. Will you use a magnetic bean? I will not use a magnetic bean. Constant stirring is just too keen. Will you find the equivalence point? I will not find the equivalence point, even when effort by Excel and Sheets is joint. So you don't like titration curves. I do not like titration curves. But you need to create one to pass the lab. Oh, okay then. And that was Titration Curves by yours truly, Dr. C. And the third one, Buffer Blues. Here we go. Buffer Blues. A little bit of this and a little bit of that. A little bit thin and a little bit fat. Buffers keep things hot and cool. Learn them now. Don't be a fool. To prep, you need the following things. Livers of newt and onion rings. Oops, sorry to my dismay. I was reading from the Scottish play. Actually, you need a weak acid and a conjugate base, maybe from Lake Placid. Have them in similar concentration. Ratios more than 10 lead to frustration. Make sure buffer pH is near your goal. Plus or minus 1 is how we roll. Then it should all work out. Your enzyme won't scream or shout. It will break up the substrate. We can all then celebrate. That was Buffer Blues. Thank you. This is All This Science. Email me with all your comments, allthisscience@gmail.com. Bye-bye.